Hello, everyone. Can I have your attention, please? Thank you. So the first science talk of the day is by Virginia Trimble, but before that, I have a couple of announcements. The first one, please, after the session, after Virginia's talk, please stay here. We're going to go somewhere, take a group picture. And the second one is we talked a lot about finances this morning, and I know that within membership there are lots of people who are concerned, would like to hear a little bit more about that. So there is a group that is going to go to the restaurant in this hotel to discuss finances, investments, etc., etc. So if you'd like to join that group, please talk to Gary Walker here, who is going to actually organize the whole discussion. And with that, we're going to the first science talk of the day, presented by, what day is it today? Saturday, the day, by Professor Virginia Trimble. I met Virginia in 2005 in Granada at a conference. So we have our 10-year anniversary. We had it last year. And we should have gotten pins. But it's a great pleasure. Virginia is working on all kinds of things, but we know her in the scientific community for her reviews. She was reviewing the literature, every year's literature, in a big, gigantic paper at the end of the year. So even when we're discussing what her presentation would be today, we had a plethora of choices. And she decided she's going to talk about exoplanets and multiverses. I picked that one because exoplanets and multiverses, really, that's really exciting. So I'm really looking forward to the talk.
Thank you, Stella. She forgot to tell you the most important discovery we made in Granada. We share a birthday. Not the year, I admit, just the day. But we, not the year, but we do share a birthday. Okay, many things happen when you get old. One of them is there comes a moment when things you remember as current events are now history. And whether for you that's World War II or Korea or Vietnam or I don't know what, but it's true in the sciences as well. I mean, I do remember before pulsars, before quasars, before the cosmic microwave background, and very much before exoplanets. I'm told that I actually coined that short, the proper phrase is extrasolar system planets. That's fine. People said extrasolar planets. That's clearly wrong. Have you ever seen a planet inside the sun? And I'm told by somebody whose name I'm not allowed to mention because he's currently in disgrace that I coined the phrase exoplanets. In any case, these both go back about 20 years to Volchan, the planets of pulsar B 1257 plus 12, and the October 1995 announcement of 55 Peg B from Mayer, Carlos, Marcy, and Butler. And now, of course, the enormous number of exoplanets from Kepler, Ilbaruki. And the concept of separate universes, that goes back infinitely far. We'll see in a moment that there was a time when an exoplanet and another universe was the same idea, because once upon a time, the Earth was the universe. What else do I want to say? Oh, there's the sponsoring agency in the lower left-hand corner. A quote, the Greeks weren't always the first to do things, but they were generally the first to write about them. L. Joyce Farmer happens to be my cousin. And in the lower right-hand corner, that's where we are. 7 May 2016 in the Anthropocene, I believe. St. Louis, Missouri, U.S., or Missouri, that's Aunt Esther. North America, Earth, Sun, Solar System, Orion Arm, Milky Way, Local Group, Virgo Cluster, Laniakea, and Universe that fell off the edge of the slide a little bit. That's not all the exoplanets. You can't fit them all in one circle anymore, but symbolically at least, those were the radial velocity ones a few years ago. And the colors are kind of temperature, and the sizes are kind of sizes. And at that stage, most of them were significantly larger than the Earth, and most of them were close to their stars, hot Jupiters and variations thereof. We do not have a corresponding easy way of picturing multiverses. That's somebody's idea of multiple four-dimensional space-times folded into six-dimensional space and projected back to two-dimensional space. Actually, what it really looks like is my trying to draw a sketch map to explain where my apartment is, but same general principle. This is the era when the Earth was the universe, and it could be circumscribed by a god in a day or a human being in a lifetime. That particular picture, that's not the rudest one. There's Geb, the Earth god, Shu, Shu's name is fallen off the bottom. Poor Frank. Not that Shu. Shu, the sky air god, holding up Nut, the sky goddess. On the left, there's Ra in his boat, and he's sailing across the sky in the day. And at night, he gets out of his day boat, he gets into his night boat, and goes under the Earth to come back and do it again. And that's why the speed of the sun seems to slow down at the horizons. Astronomers should know this. If you're watching the sun carefully, through dark glasses, of course, you will notice its apparent speed in the sky slows down at the horizon, both morning and evening. That's Ra getting in and out of his boats. Isn't it? That's what my mother said. And there is the universe of Hildegard of Bingen. Several things in that. She's lost track of the fact that the church is going to make everything spherical. But more to the point, it has an interesting arrangement of stuff around the terrestrial world. Hail and lightning are outside the stars. Clouds are close, that's okay. The moon is closer to us than the inner planets. That part's okay. But the arrangement of several things is not the standard picture. There's a sense in which she flourished in a time of relative intellectual freedom. You get relative intellectual freedom when nothing is threatening you. That, I think, has always been the case. And whenever organizations feel threatened, they close in on what you're allowed to think or say. Giordano Bruno wasn't burnt at the stake for multiverses. Giordano Bruno was burnt at the stake for saying that some of these were better governed than Rome under the popes. And the Pope was feeling threatened. This is not a good thing to say. We don't now generally burn our colleagues for saying that other countries are better governed, though we've been known to fire them from jobs occasionally for that sort of thing. So there's the universe of Hildegard. Next to it is the universe of Martin Luther. Again, a geocentric model with all the astronomical stuff around, and outside a prime mover. Oh, yes. That's Copernicus. That's Copernicus at volume 1. With everything circular, it looks lovely, but of course it doesn't fit the observations at all well. Volume 2 of Copernicus puts back all the epicycles you need to fit if you think you're going to do everything in circles and spheres. And Copernicus doesn't really need fewer epicycles than Ptolemy did. The claim that Ptolemaic cosmology collapsed under epicycles just isn't true. Copernicus needed just as many. The only change he made was to put the sun at the center. But those of you who have made observing plans know that when you plot what you're going to observe in the sky, you pretend that the Earth is at the center, don't you? Nobody does an observing run by starting plotting where things are relative to the sun, unless you're a solar astronomer and your satellite is an endoplanet. And there's Sir Thomas Digges. His view was that the stars are suns. By 1600, this was not yet accepted everywhere, but it was a possible idea. His idea was the stars are suns, and each of them has its own system of planets and other stuff. And he ran out of papyrus, actually, basically, was the problem. He couldn't draw an infinite number of stars. Vellum and papyrus in those days were quite expensive. Even now, we don't do well storing an infinite number of stars on anything, though LSST is going to begin to make us try to do that. It also, LST, has a transient working group. It's the sources that are transient. The working group is going to go on forever. I like this one. Spectacular, isn't it, son? In fact, astronomers say there may be billions more little white dots beyond the border of this cartoon. Which is true. The universe now, and for many years, it may be infinite, but it is in any case large compared to what we can survey. Here's some fine-tuning from 1974. It was the first year I gave a talk called Cosmology, Man's Place in the Universe. I gave it at DuPont up in Rhode Island. Any case, 4 forces: gravity, electromagnetism, nuclear and weak interaction, and 4 large-scale properties: Hubble's constant, which is in effect an age for the universe, the density, the entropy or the temperature, and the small deviations from homogeneity and isotropy. And that those are actually slides left from when I gave the talk back then. Some of the numbers are interesting, and it was Dirac who first noticed, for instance, that the ratio of gravity to electromagnetism between two elementary particles is 10 to the minus 40. Gravity is weak. It keeps you in your chair, but the chair, this sleazy little, built by the lowest bidder chair, is fighting gravity of the entire Earth and winning for most of us, most of the time. And there are other relationships among these numbers. The actual density is very close to the critical one of 8 pi g rho equals 8 squared. The temperature fluctuations are parts in 10 to the 5. The photon to baryon ratio is and always has been something like 10 to the 9 or 10 to the 10. These numbers are fairly stable. Actually, to Dirac, they weren't. He thought that G was getting weaker as the universe expanded. That now doesn't fit existing data. And we all claim that science is a self-correcting process. If you predict something and the observations disagree, then you're supposed to go predict something else. This happens most of the time, but not always. I don't want to focus on any of the examples you are now thinking of for a variety of reasons. I will only mention Barkla. Barkla won the Nobel Prize that should have gone to Henry Moseley. Moseley was killed at Gallipoli. Barkla won that Nobel Prize, but he went to his death 30 years later, still thinking that there was a J shell of electrons around atoms inside the K and L that we know about. He never got over that. Nah. Ah, yes, okay. Exoplanets as they were in 1974. Are we alone? This is another version of what you probably know as the Drake equation. It simply says that if you have a whole bunch of stars and quite a few of them have planets, the ones mostly that are not in binaries, and you want stars that live a long time, so you leave out the OBs that are short-lived. You want them bright enough to have a reasonable habitable zone with some ultraviolet. You leave out the M stars. You get down to having 10 to the 9 or so habitable planets. And that number is now very much better confirmed than it was when I made up this slide several years ago. The meanings of the fact that things that seem to be finely tuned to permit chemically based life and intelligence, at least among a subset of us, and we argue about which subset it is. The only wisdom I have to bear on this came from my mother. She said, if they were as smart as us, they would have our jobs. But possible meanings, God has been very careful. I mean, that may be the right answer. It's not useful because it doesn't lead you to any more observations or calculations or ideas. Multiplicity of universes, that was my number. That was actually my first choice in 1974. It still is. Another possibility is more physics. If something like grand unified theories or supersymmetry comes through for us, which may yet happen, though after 50 years we're beginning to kind of wonder about this, it is possible that we'll be able to predict things like the value of Hubble's constant and the ratio of the charge to mass of the electron and all this fundamental stuff. Finally, it may just be complexity. Maybe all you really need is an enormous number of particles and several different ways for them to interact. The general idea is you can calculate the structure of a water molecule. The Mickey Mouse ears of the two hydrogens sticking out from the oxygen, and its energy levels. Nothing in that would lead you to predict waterfalls or ocean waves. That simply arrives from a large number of particles interacting far beyond our ability to calculate it. That actually was Richard Feynman's view of these fine-tuning things when he could be persuaded to think about stuff like that. Like most great scientists, he has a number of stories connected with him. There are also Dirac stories. If we have time at the end, I'll share a Dirac story. I have a good Dirac story. My very own. He gave it to me because he liked me. If Dirac liked you, he gave you your own Dirac story. Richard, I think, didn't do that. In any case, those four possibilities, I think, still exhaust the universe of discourse if we expect to be able to understand why our universe is habitable. Timeline. Once upon a time, we were unique. There was an Earth, it was the universe. Then other planets in the solar system, that was Copernicus, that they might be habitable. I just understood the problem. You're supposed to press outside the green circle, not on it. Okay. William Herschel. Herschel thought he'd seen caves on the moon with tall trees growing outside them. And he didn't actually publish this, but he sent a letter to the then Astronomer Royal claiming that this was true, and that letter has been preserved. But the idea that everything was inhabited lasted well through the 19th century. Were any of you allowed to read the stories of Dr. Doolittle when you were children? Anybody remember Dr. Doolittle? Remember Dr. Doolittle and the Moon? Got a few nods. Okay. Everything was inhabited. And then that turned out not to be such a good idea after all. But then the stars are suns, and ours is typical. Spiral nebulae are galaxies. This was Curtis and Shapley with a good deal of unhelp from Van Manen, who thought he had seen spiral nebulae rotating in the plane of the sky, and their speeds would have been larger than the speed of light if what he had thought he had measured was true. We still do not understand what he did wrong. The Hipparcos coordinate system in the sky has some rotation as well. I'm told that that is not the cause. It's not a result of anything similar to what Van Manen's problem was, though in both cases it was a systematic error that was large compared to the statistical error, like Hubble's own value of the Hubble constant. Exoplanets common but different. Multiverses, anything that isn't compulsory is forbidden. Anything that isn't forbidden is compulsory. Maybe there's a whole range of possible properties out there. Do multiverses exist? Andre Linde said he would bet his life. Martin Rees said he would bet his dog. And Steve Weinberg said he would bet both Andre Linde's life and Martin Rees's dog. Andre Linde is still alive. I'm sorry to report that Martin's dog died and had to be replaced, but it has been replaced. Exoplanet candidates, we're up, they're 10,000 or something. Gale will have even more. And this is one of those cases where somebody who was very, very stubborn was right. Bill Barucki fought for Kepler for something like 30 years through a succession of demonstrating that the required photometric accuracy to see planet transits was possible, and that the equipment could be designed and it could be made space ready. More of a one-person project than most of the things that now happen in science, and he has quite properly received several prizes for it. Oh, the green light's going out. That's a bad sign. We'll see what happens next. Oh, what do we need for habitability? A planet, you want liquid, solids, and gases. You probably need a source of high-quality energy. You need a sink for heat. That's easy. The universe is cold. You radiate to the universe. Plate tectonics, not just for land sea mix, but for ores, fossil fuels, are products of heating and compressing at plate boundaries. So in the absence of plate tectonics, there would be no oil to buy stock in. I'm trying to advise the finance committee, see. A largish moon to stabilize the rotation axis, a magnetic field, which requires rotation, the star not too violent, not too many supernovae and gamma ray bursts nearby, and the top things I think are more important than the things at the bottom. Now, what does it take to make a habitable universe? Some of the same things in a way. You need a lot of stuff. You need 3 + 1 dimensions. 3 spatial dimensions are apparently vital. A 2-dimensional space, and you cannot have complicated networks. You have the problem of connecting, 3 houses to the gas, the electricity, and the water without any of the pipes crossing. There's another well-known Greek puzzle of the bridges of some town, the name of which I forget. But it's the same problem. In 2 dimensions, you can't connect up much in the way of the grid. And you need only 1 time dimension. Oh, sorry. If you have more than 3 spatial dimensions, you no longer have stable circular orbits. 4-dimensional, 5-dimensional space doesn't give you stable orbits to keep something the same temperature. If you don't have any time, everything happens at once. This is very inconvenient. If you have, or nothing happens at all, yeah, perhaps. If you have 2 time dimensions, you don't have causality. And my words are roughly right, but the actual demonstrations belong to much smarter people like Roger Penrose. multiple forces with a range of strengths, multiple kinds of particles with different responses to the various forces, processes that form structure and time. I don't think you really need a precise ratio of electromagnetism to the nuclear force so as to make the carbon to oxygen ratio near 1. If it wasn't carbon, it would be something else. I mean, carbon happens to make really nice complicated molecules, but if there were no carbon, the periodic table would be different enough, there would be something else that made complicated molecules. So I think this is not the kind of fine-tuning we need. This assumes you're trying to make something kind of like us. We're not typical. We have one star. The stuff is mostly coplanar, except the comets, co-rotating. Small rocky planets up close. Large gaseous is missing one of its S's, isn't he? Far out. You trickle off to Kuiper belt objects, the Oort cloud and zodiacal light. Everybody else, hot Jupiters came first, and then this, I think, is the trend to carry away in your mind of exoplanets. As we've developed more techniques and used them for longer periods of time, the range of masses, compositions, sizes, orbit parameters, types of host stars, all of these have expanded monotonically. So that it's now hard to say that there's any kind of star that never has planets. Even white dwarfs have planets. All stars have planets. It's very, very hard to say that there's no possible star-planet combination that never occurs. Binary hosts, yeah. Some false alarms. Evidence for clouds and atmospheres and water vapor and exozodi. Exozodi is bad if what you want is to image the planet. I think that's probably never going to be an AAVSO task, although transit planets may very well be, as Stella was saying a few minutes ago. Spin orbit misalignments, the Rossiter-McLaughlin effect. Every trade has its trade secrets. One of them, they're secret handshakes. Any other members of Sigma Xi want to do a secret handshake? But there's vocabulary as well, calling things by the names that the profession uses. And if you want to have your question taken seriously, you need to ask things in the vocabulary of the profession you're addressing. The Rossiter-McLaughlin effect says that if you have a rotating star and you cover over part of it, it will change what you think is the measured radial velocity because you're covering either the side going towards you or the side going away from you. It's seen for planet transits. 2 comet families around Beta Pic, disks with gaps, transit planets, new dust clouds. People are forming dust clouds now. That particular star in the cluster NGC 2547 is apparently experiencing something like our late heavy bombardment. The Earth as a planet, when you look at Earthshine during a moon eclipse, or when you see the old moon in the new moon's arms, you're seeing light that has been reflected by the Earth to the moon and back again. The moon has no atmosphere. So what we see in Earthshine is the Earth's atmosphere affecting light that's gone through the atmosphere twice. And from that you can learn what the Earth's atmosphere is made of, which you may have to do if the session doesn't end in time for you to get outdoors. Earthshine, looking backward, you can see from photometry of the Earth done in this way that there's land and ocean and vegetation, oxygen, methane, the red edge is due to vegetation. Europa has plate tectonics. The claim that arsenic could replace phosphorus turned out not to be true. But I still think that there is more freedom of composition than we see in our own solar system. Remarkable planetary systems, all of whose names from your point of view are splodge. But you could look them up for yourself. It's the first of each thing. The first with 3 Neptunes, the first with a transiting hot Jupiter, the first with a super Earth, ... That's even worse. Can't even tell what that's supposed to be. Okay. Oh, okay. That's a list of functioning or approved. That's a list of functioning or approved Doppler surveys for planets, of which there are an enormous number. That is somebody's idea of an exoplanet with stuff on it. We now are going to have correlations of properties. And again, the main point is that these graphs have filled in as technology and lengths of surveys have increased, so that to first order now we don't see strong correlations of planet mass and orbit period, planet composition and orbit period. What we do see is you get better and better at doing small radial velocity amplitudes as time goes on, from 1988 to 2013 or 14. This was correlations of planets versus size for M5s. The key point here, when people had first only looked at solar type stars, GKF, FGK, they found that only metal-rich stars had planets. That's no longer true. Our metal-rich stars have planets, but so do metal-poor stars, particularly low-mass planets and low-mass stars. So that correlation of having planets with metal-rich composition for the star is no longer true. I remind you that we count things hydrogen, helium, metals, just as very primitive chemists go methane, ethane, paraffin. That's only funny to chemists. And maybe anthropologists, you know, the tribes that supposedly go one too many. I don't think it's really true. In any case, many of these correlations disappear as you get a larger sample. There's the thing versus composition with the early ones and the more recent ones, and that effect has essentially gone away. This one is masses and semi-major axes of known planets. And this is a couple of years old. We'll see a more recent one right at the end with some pretty colors. Except that projector, the colors on this projector are not as pretty as the ones that I drew as I was making up this presentation, which were nice bright marker colors on paper. That is planet radius versus orbit period. Again, there is some correlation. Well, in particular, you can't have a planet that is bigger than its distance from its star. That doesn't work. And so that cuts out a corner. But again, the correlation has gotten less and less strong with more and more data. Again, versus time and masses. And as time goes on, we've found lower and lower mass down to Earth mass planets. That's another one on the separations of planets where you have multi-planet systems. There are now oodles of these, anything from 2 planets up to something like 7. And they are virtually all stable by standard criteria associated with names of hill and people like that. To first order, you need a 3-to-1 ratio between separations versus distance from the star. Density versus mass, well, that makes sense. Jupiters are mostly gaseous, Earths are mostly rocky. Planet radii versus mass. Oh, and the lines there are models of planets with different compositions. And the key point is the planets observed fill in essentially the whole space. So there are planets that are as dense as the Earth. There are planets that are less dense than Jupiter that must be just almost all pure hydrogen and helium, which Jupiter is not quite. Another one for Neptunes and super-Earths, again, the data simply fill in the whole plane of possible compositions, partly water, partly rocks, partly ices. That's a transit. There's a shallow transit when the planet goes in front of a star. There's a deep transit when it goes in front of a much less bright star. That is off-center distortion of the shape of the star by winds and the shape of the planets. That's a Spitzer-like curve for a particular one. And it means off-center, well, you can see the brightest spot is not quite at the subsolar, the substellar point. Off-center winds, these planets must have weather in the sense of things that change. What's that? Oh, here's our friend, the Rossiter-McLaughlin effect, that simply distorts the velocity curve. That is a bit of spectroscopy. You know, when a star compared to the planet is brighter by a factor of 10 million or something, so doing spectroscopy on the planet is not easy. It's generally done differentially by getting a spectrum of the two apart in the sky, then as the planet gradually goes in front or in back, and then of the completely occulted planet. And you can get some information about the planet spectrum. There are planets with water, there are planets with CO2, CO. We have not yet seen the standard signature for biological life. A planet that you know has complicated chemistry, life chemistry. we'll have things that couldn't coexist. The classic combination is ozone and methane. Methane will be eaten up by the ozone very quickly, unless they are both produced continuously. The ozone, of course, oxygen from plants. The main source of methane, I'm sorry to report, is not really bovine flatulence. It's termites eating wood underwater and stuff like that. But again, complex chemistry, life chemistry. Haze. This one has no features at all. It's just a dusty, hazy atmosphere. Kinds of multiverses. I think virtually all of us would say that our universe is bigger than we can observe. There's no doubt about that. We keep pushing to higher and higher redshifts for galaxies, for quasars, for supernovae, for gamma ray bursts. And you can go on beyond that. So beyond our horizon, and the same physics, I think it's not controversial, beyond our horizon and different physics is possible, but I think less popular. And then you come down to the kind that some people believe in, sometimes people don't. My favorite is undoubtedly whoever many worlds. Parallel worlds diverge. Tegmark, a distinguished cosmologist, says this has the same kind of experimental basis as the theory that there were dinosaurs. Tinkerbell asked if you believed in fairies. Raise your hand if you believe in dinosaurs. Okay. Shall I ask if you believe in fairies? I think not. Oh, Stella believes in fairies. Bravo. Very good. Kind of depends on what you mean by the word, doesn't it? The vocabulary has changed with time. In any case, what Tegmark said was that the feeling that there were other universes diverging from ours anytime an unsteady atom decays made it easier for him to make decisions. Jean-Paul Chrétien in New England Journal of Medicine a couple of years ago said the same thing was true for doctors. What I really want to know is if he's a relative of the astronomer Chrétien. Many worlds in science fiction. There's a bunch of neat stuff by John Wyndham. Psychological many worlds. That was William James. He invented the phrase multiverse. And Oliver Sacks defined it as meaning non-integrated minds. I think those also exist, right? Connected with different physics. You can have a sort of decision tree. If you want to get all the physics right, maybe it predicts a unique value of lambda and everything else. In that case, no multiverses. Or if there are, they'll all have the same physics. But maybe even when you get all of our physics right, you can predict a range of different possible things. If so, then that's interesting. Sequential in time, not if our understanding of GR and singularities is correct. Coupled to physics beyond the standard model and beyond, brain collisions in higher dimensions, multiple axion fields, Mark Kamiankowski's making a living out of that, dark matter and dark energy, false vacuum decay and bubble nucleation, that's Alex Vilenkin's territory, seeded from black holes and cosmological selection. I find this one very strange. This is Lee Smolin. His idea is that a universe that produces many black holes will also bud off many other universes. So that pretty soon you have lots of universes and they all have lots of black holes. And since we have lots of black holes, he claims that this shows that we came out of a multiverse ensemble. I'm not sure. I think that's bad. It's backwards somehow. I don't know. But several of these do have testable consequences in terms of details of the microwave background and whether you see the G-mode polarization, in terms of properties of black holes, which LIGO is now beginning to bring to us. We now know the spin of one black hole quite accurately. The one that was formed in the LIGO event has a spin of 0.63 of the maximum possible. They didn't have enough data of the incoming spiral to get the spins of the incoming black holes. When there are more LIGO stations, when Virgo is up, GO6, the Japanese one, the Chinese one, the Indian one, we will get polarization information that will tell you about the spins of the incoming black holes, which again may have some information to say about possible multiverses. Baby universes, internal inflation. People win prizes for these things. Now, what is inflation? There's the inflation. The multiverse. This is a Bernard Carr version. It's like the snake that swallows its own tail. And the grand unified theories span between the very large and the very small. The strong and weak interactions go in the middle, and the electromagnetic is where we now live, in apart from large-scale things, our lives are dominated by electromagnetism. That's the structure of a chair, the structure of your heart, and all the rest. These are 4 possible kinds of multiverses. The 4 I just mentioned. Bigger, but same physics, bigger, different physics, higher order dimensions, and inflation type coupled things. Lots of choices. And it's possible to think that some of these are likely and some of them are not likely. There's the decision tree. If you have a fundamental theory, either it gives you many possibilities or it doesn't. And you then ask, does the universe we live in this ensemble of multiverses in a common likely corner? I'm not sure that this is a decision that you need to make. Lord Rees thinks it is, in the sense that if you end up saying that we live in a very unlikely corner, then the multiverse is likely to be wrong. What are you looking for? Okay. Whatever. Where were we? Okay. I don't know whether we live in a likely universe or not. I know that our universe has a probability of 1 because here we are. Those, again, are possible regimes of space and time, some of which are inside black holes, so you don't want to live there. There's the Chandrasekhar limit and the equivalent for neutron stars. There are main sequence stars and the Earth and the universe as a whole. Some of these will be habitable and some won't. There's the thing about dimensions. And if you believe all of this, the only possibility is we are here, 1 time dimension and 3 space dimensions. And I think that's probably right. Again, time domains and mass domains where bound structures can form for different values of the radiation domination and the age of the universe. And is there time for a hot universe to cool to make structure? You have to allow, if you want our universe, you have to allow for everything we see to happen. Again, a regime, the cosmological constant. I can't see that there's any reason that the cosmological constant couldn't be 0. I mean, Einstein changed his mind several times, as he did about gravitational radiation and other things. But if the cosmological constant is too big, you don't get structure formation. That's true. But I see no reason why it shouldn't be 0. In fact, on the scale, on the right scale, where you write down the general relativistic equations that involve the density and Hubble's constant and lambda. Lambda is in fact comparable with the other terms in that equation. And that seems to be perfectly reasonable. There are particle physicists who say it should be larger by a factor of 10 to the 120. That would not be a habitable universe. Again, the fine-tuning of the electromagnetic and strong coupling constants. Again, we are here as a very small corner, but okay, so carbon is unstable. If carbon is unstable, you get something else. I think that's not a criterion. This is Lee Smollen's natural selection of universes. So down at the bottom there, all the universes have lots of black holes because the ones that have no black holes have no offspring. I think that's like the description of heredity given by some school child, supposedly. If your father had no children, then you'll probably have no children either. So there's a universe that had no children. That's a habitable universe. Again, an artist's impression of trying to put 5 dimensions into 1 or something like it. This is a science writer's view. There are going to be 2, this picture goes across 2 screens, but he's trying to picture himself in a multiple of universes. One of them he's a movie star when he's rich. Another one he's poor and homeless. He's king of something or other. Lots of them are dead. In one of them he's Rowan Hooper who's writing the article. And there he goes off into infinity. Warm planets orbiting cool stars. Those are almost but not quite photographs. We're getting there. Oh, that was supposed to be such pretty color. Pooh. That's Hugh Everett's multiverse of all the branching straight things that separate each time some one particle decays and either the cat dies or the cat doesn't die. If you've ever worried about Schrodinger's cat as some kind of intellectual paradox, it has a simple answer. The cat is the observer. The cat knows immediately whether the gas has been released from the capsule or not. You do not need a human to come look. We had a long talk on the philosophy of Schrodinger's cat a while back at the University of Texas, and I didn't claim to understand it all, but I went up to the speaker, a very distinguished person, but by then I was old enough not to care what distinguished people think about me, and I said, "You mean the cat was the observer?" And he says, "Yes." So that's the answer to that one. But this is a really pretty Spanish fan when the colors come out. But just in case, in this plethora of possible multiverses, which I still think is the right answer, because first there was a planet, then there were a bunch, there was a star, and then there were a bunch. There were clusters and a bunch, galaxies and a bunch, superclusters and a bunch. Every case, the people who said many were right. The catch is no multiverse theory can tell you how much life there should be in a given cosmos, how exceptional life on Earth is. I think it's probably right. It's from an LA Times editorial. And the next column was consensual citizenship, which is the idea that merely being born here shouldn't make you a citizen. You have to agree to behave decently, approximately. Planetary systems in the Milky Way, Gene said there were maybe 6, maybe 60 billion. And this is a case where data forced people to change their minds. I mean, Gene thought that the Milky Way had very few planetary systems because you only got a planetary system when one star passed very close to another and dragged stuff out. The encounter hypothesis, Trimble and Moulton. But now we have data. It makes a difference. And there we are with planets. Again, they've lost all their pretty colors, but on the left was the stuff from a couple of years ago, and on the right is what has been filled in from Kepler, which is enormously impressive. I think this is probably the last. Yeah, I have just time to tell you. You're going to have 4 minutes for questions, but this is the last image. So you have to choose whether you want a Bill Baruchi story or a Paul Dirac story. How many of you want a Baruchi story? How many of you want a Dirac story? Okay, we have a Dirac story, but I also have finance stories. Okay, we now go back to 1972 in Verena. Do I mean Verena? Yeah. There was a summer school. There were a bunch of summer schools. There was one on the history of physics that was just coming to an end, as one on gravitational radiation was just starting. This requires a couple of pieces of background information. One is that Paul Dirac was by then interested in the history of physics because he'd been so much a part of it. A second is that for 28 years I was married to Joe Weber, who built the first detectors for gravitational radiation, and that was why we were at that meeting long before LIGO. Okay, it was clear at that stage that the Maryland work on gravitational radiation was not going to be greeted with acceptance by the whole community. There was a graduate student whose name I do not remember, but it doesn't matter for the purpose of this story. And he looked at me and he said, "Don't worry, Professor Weber, only a dead fish goes with the stream." Now, okay, silence. Finally, Dirac says, "Algae. They also go with the stream." That was a perfectly characteristic Dirac remark. It was perfectly true, it was relevant, but it was very brief. I think this is the last image. Yes, we've now seen that once upon a time the Earth was the universe, and there were many things orbiting the sun, many stars, many galaxies, and each time somebody has said one and somebody else has said many, the manys were right, as clearly that's now true for stars being orbited by planets. The solar system is not in any sense unique. There are enormous numbers of planetary systems. I think it's probably true for universes as well. Let me stop at this point and invite questions, comments, or rude remarks.
Questions?
Or comments or rude remarks.
Or comments or rude remarks?
No rude remark from me. I've been reading recently about a group of folks who think that we might be in a simulation. Any thoughts on that?
I believe some of my acquaintances are, but not all of them. Okay, this is part of the general idea of where is our civilization going. If someday everything is going to be silicon dominated, then there must be out there amongst these billions of inhabited planets many that are far in advance of us and are not carbon-based. They're diodes or something, in which case we're not quite a simulation, but we're the zoo that they visit on weekends. Particularly, the non-custodial fathers have to bring their kids to see something. And so we're visited by non-custodial fathers of very advanced civilizations. But the idea that instead of silicon-dominated machines, it'll be silicon-dominated simulations is that same sort of idea. Where are we going? And if we are going in that direction, surely somebody got there ahead of us, and so we are the product for their getting there. But that assumes that there are people who got there ahead of us. I don't know that that's true. I don't know that it's false, but I'm not at all sure it's true. I mean, there are days when you feel like a simulation, right? And you wish somebody would hit reboot. I'm not sure it's right.
More questions?